Namaskar दोस्तों, welcome to channel Toxicology on board. Today in this video we'll be discussing another DABT topic, that is relative risk and attributable risk with respect to risk assessment related from the ABT brochure. So let's directly dive into the questions. These questions are taken from ABT, American Board of Toxicology, recertification question papers, year 2001, part C, as well as year 2000. These questions are old type of questions. Now no longer this type of format questions will not come in exam, but the concepts still are part of DABT syllabus. So we'll be discussing the concepts which are related to this risk assessment, because around 30 plus marks with respect to risk assessment you will be having in the exam. So let's see what are the questions. The first question is the ratio of incidents in exposed workers compared to the incidence in unexposed workers is. So we need to see what is the ratio of incidence. We have option A, relative attributable risk. Option B, we have relative excess risk. Option C, we have relative risk. Option D, we have odds ratio. Option E is none of the above. The right answer will be in the green text, that is relative risk. So you have question 1, question 2 and question 3. All these three questions, they are mentioned under the recertification examination papers. All these three questions are with respect to relative risk only. So if you understand the concept, what is relative risk, what is attributable risk, what is odds ratio, then what is absolute risk, if you understand these terminologies, any question with respect to this concept you will be able to answer in the exam. Okay, let's see what was the second question. The ratio of incidence rate, similar to that of the first question. See, ratio of incidence rate in the population exposed to the risk factor to the incident rate in the population not exposed. So basically the meaning is here incidence rate is nothing but relative risk. Okay, and what is the formula is population exposed by population non-exposed. So you have to look into the option. So the relative risk definition is uh, this particular statement is applicable to relative risk. So in this video we'll also understand what is attributable risk and what is absolute risk. Also we'll discuss it upcoming next slides. Another question also came on the same concept directly. What is relative risk? Only that question. Relative risk is, we have to identify the which of the following statements is applicable with respect to definition. So option B was right. The ratio of incidence rate of diseases in exposed to incidence rate in the unexposed group. Population exposed by population not exposed. So here if you look into other options, no, option number E, that is proportional excess risk of diseases that is associated with the exposure to a risk factor, it is applicable to option A, that is attributable risk. Okay, here not the entire population, here a proportional excess risk of the disease which is associated with exposure to a risk factor. Okay, so what is the explanation which was given by the previous students is, in if you look into the statistics, no, and mathematical epidemiology, relative risk, that is RR, it is the risk of an event or a developing disease relative to the exposure. Relative risk is the ratio of probability of the event occurring in exposed group versus non-exposed group. So by the end of this slide, what you have to understand is definition of the relative risk. Okay, now we'll see another question with respect to attributable risk. This question was also taken from ABT recertification paper 2000. So what is the, directly they have given the statements, the definition statements. So attributable risk can be defined as the proportional excess risk of disease that is associated with exposure to a risk factor. So rest of the things are odds ratio, relative risk of disease in two different population, these are not applicable with respect to attributable risk. Explanation is, if you look into epidemiology, attributable risk is difference in the rate of condition between an exposed population and unexposed population. Okay, so you have to understand the difference between relative risk and attributable risk. In case of relative risk, population exposed by unexposed population, whereas in the case of attributable risk, it is proportional exposure is there. Okay, so we'll see what are the other options. One of the options and one of the question we had about with respect to odds ratio. So what question we have with respect to odds ratio? from the previous set of questions is an odds ratio obtained in a case control studies. If you look into epidemiological studies, no, we'll have different type of studies, statistical studies, mechanistic models will be there. I'll discuss with them what are the control cohort studies, what is prospective study, what is retrospective study, case control studies. I will discuss in another video. Okay, so in that we have different types. No, one is case control studies. In the case control study, only you'll come across this term called odds ratio. An odds ratio obtained in a case control study serves to estimate option A case fatality rate, option B p value, option C is F statistics, option D is relative risk, and option E is disease prevalence. The right answer will be relative risk. So this is a definition. It is a part of relative risk odds ratio. Okay, odds ratio. It's a technique for estimating relative risk from case control studies. Okay, we are slowly trying to get to the questions. Concepts also we will learn eventually. Okay, another question they asked with respect to excess risk in the case of ABT recertification only. So they have given a formula: excess risk is equal to Q into D, where Q is there. So we need to identify this formula and we need to understand what is Q. We have option A, that is 95% upper confidence limit on a risk per unit dose. Option B is normally distributed population of a quantal dose response. It appears to be like a binomial distribution curve. Percent of positive cancers found in a lifetime study, logarithm of potency of the test substance, lifetime average daily dose. This is something like LADD. You have separate formula on that also, expressed as mg per kg per day. So out of all these options, excess risk is something related to 95% upper confidence limit on risk per unit dose. So what is the explanation we'll see? The excess risk refers to excess rate of occurrence of a particular health effect associated with exposure to, for example, a radiation or chemical. If you look into the formula, no, R, which is denoted as nothing but excess risk, Q into 1, where risk is given in terms of mg per kg per day. Maybe it might be Noel or any point of departure, and exposure. Exposure is also given in mg per kg per day. So go back, you can go back and look into Springer's, whatever the risk assessment textbook is there, no? In that you please read about this one, all the type of terminologies with respect to risk. So in the this is the book I was suggesting you, which is mentioned in the ABT brochure also, Toxicology Risk Assessment of Chemicals. So I have pulled out some of the important key terms with respect to risk assessment, which will better help us in understanding the concept with respect to risk. So first we will see what is the definition of the risk. Okay, this particular textbook, it is there in the ABT brochure in the syllabus. So you have to read one textbook with respect to risk assessment. So coming to risk, no, probability of an adverse event in an organism, system, or subpopulation caused under specified circumstances by an exposure to an agent. So, for example, to understand this risk, no, let us take some discuss with some examples. For example, there is a certain laboratory, certain pharmaceutical industry, and they are working with some solvents like formaldehyde, or for example, they are working with formaldehyde or styrene. If there is a leakage, and there is a laboratory accident is there and a spillage is there, leakage of a styrene gas, so in that case styrene will be the causative agent, that chemical will be the hazardous, that will be the risk. Okay, now the management or the laboratory scientists will sit and decide how much amount of the spillage of styrene has taken place at the time of spillage, immediate exposure in that particular room or area, containment area, how many workers or scientists were working. Okay, immediate exposure, acute exposure, then they will make based on the physicochemical properties of that particular gas, how much area it has been vaporized, and they will make some zones like zone 1, zone 2, zone 3. Okay, and they will also decide based on the what are the target organ toxicity, what are the acute toxicology symptoms, then they will try to evacuate that exposed area. If there are common population are there, they'll try to evacuate that particular area. See, whenever we are discussing, no, you think about like Bhopal gas tragedy, or you think about a Sivosa disaster, or you think about a Chernobyl incident, or in Japan that nuclear accident which took place. No, so those are the risk-prone area. Okay, the hazard has happened. Then what immediate measures the management or that particular area, how we are going to contain it, that comes under risk. Okay, the probability of an adverse effect in an organism, there the organisms might be plant or immediate research scientist also, or the population system subpopulation caused under specified circumstances by exposure to an agent. So we'll see what is the second term. Second term is risk analysis. Risk analysis is a process for controlling situations where an organism, system, or subpopulation could be exposed to an hazard. For example, CVOS disaster was there, where TCDD was exposed because of the industrial accident. Okay, for example, Bhopal gas tragedy was there. Methyl isocyanate was released into the atmosphere at that time. So there, the factory workers, the main management will sit and even government and policy makers will also come into picture. They will see how much gas has been leaked. Is there any further threat is there that more amount of gas will be released into the atmosphere? So they will make zones, zone 1, zone 2, zone 3. They'll try to evacuate those areas. Okay, there should be some people to mitigate that risk. So complete evacuation will not take place. Some of the still scientists will be there on the location, still working to mitigate or further to stop further exposure of that chemical. Okay, so risk assessment, risk management, and risk communication. Risk communication is what accident took place. Now you have to communicate to the immediate. You have to isolate that particular facility. You have to evacuate that particular factory, and also you have to communicate with the nearby living population. Okay, so let's understand what is the risk assessment, which is a part of the risk analysis, a process identified to calculate or estimate the risk. As I told you, for example, in the case of Bhopal gas tragedy only, if methyl isocyanate was leaked, how much amount was leaked? When the burst took place, how much amount was there? How much is still in the container and still it is about to leak? So you have to calculate, you have to estimate the risk to give to a given target organism, not only physical hazard also if there are around 10 immediate scientists who are exposed to that particular chemical, then you have to make a note, this much amount of the chemical that particular person was exposed through oral route to dermal route and inhalation route, and how much time he was exposed to that particular chemical. You think about radiation hazard also. For example, Chernobyl accident was there. Okay, so in that radiation workers were exposed, so how much amount of or how much duration they were exposed. So different target organism, system, subpopulation, because when such a factory accident takes place, the nearby cattle, sheep, poultry animals or birds, they also get affected. So we need to discuss about that subpopulation also when we are preparing the risk management plan, including the identification of the attendant uncertainties. Okay, there might be lot of data gaps also. Those uncertainties also you have to give additional some uncertainty factor to address that risk following exposure to a particular agent, taking into account the inherent characteristics of the agent. Inherent means if it has a certain functional group or certain characteristic which is specific to that particular chemical. Okay, that's why we need inherent dose. Or like you can also look into physicochemical characteristic, permissibility or permeability, bioaccumulation. So those things also you need to, which are specific to that particular agent. That is called inherent characteristic of the agent of concern, as well as the characteristics of the specific target system. Who is exposed? Are the males exposed, or the females exposed, or the cattle is exposed? For example, you have to think about Lake Neos limnic eruption also, where carbon dioxide exposure took place. Okay, a volcanic eruption in the Lake Neos, because of which density of this carbon dioxide it came above the layers, and the entire village was under the bed of this carbon dioxide. Okay, so in that area cattle were also exposed, children were exposed, females were exposed, plants were exposed. So we need to consider the characteristic of the specific target system. Okay, Then next we'll see the risk assessment process. It includes 4 steps. This is the basic thing. Everybody, many of us already know about it. That is hazard identification. For example, in the case of Chernobyl accident, we need to identify the hazard was methyl isocyanate. Then we need to understand the physicochemical properties of that particular gas, whether it is liquid state, gas state, what is the boiling point, or what is the vapor pressure, what is the density, what is the solubility. Like this, hazard identification is important. You need to have MSDS also at your place. So what the, if there is immediate exposure, how to do, you have to look into section number 11. Okay, you need to see the GHS categories also, how to handle that one. And under section 8 also you have to understand if the spillage is there, how to address that particular chemical. Okay, second one is hazard characterization. In this hazard characterization, you will this is synonymous with the dose response assessment. If you are able to identify the chemical and if you are able to pull out all the toxicology literature, then you will be able to establish dose response curve, dose response assessment. You will be able to establish a relationship between the dose as well as the response. Okay, because of which you will be able to derive a point of departure. Okay, third step is exposure assessment. How long, how much duration, which population, that is risk characterization is deriving. You have to calculate or estimate the risk. For example, in the case of impurities, we are calculating permitted daily exposure. In the case of a radiation hazard, you'll be calculating the sieverts, in terms of sieverts, how much radiation was there. So like that. So if you look into the risk analysis, no, this risk assessment is the first component in the case of risk analysis. Okay, so we'll see some more terms with respect to risk only. So we have risk characterization. Risk characterization, it is a qualitative, sometimes wherever possible quantitative. Qualitative means how you cannot quantify it number 1, 2, 3, or in terms of units you cannot do it. Certain times yes or no, very severe, moderate, like this, qualitative. Whereas in the case of quantitative, you give some number. Okay, this much amount of exposure, 20 gram to 30 gram, or 20 mg per ml, or 20 ppm, like that. You will be able to give quantitative determination, including attendant uncertainties of the probability of occurrence of known and potential adverse effect of an agent in a given organism, system, subpopulation under defined exposure conditions. Whenever that particular accident is took place, first they will try to contain that particular region. They don't want to spill that particular chemical in expose the threat area. For example, in the case of biohazards also, if there is a leakage of any virus, once you identify, they'll try to seal that particular floor or particular facility. Okay, so that further exposure of that area, they'll try to minimize it. So risk characterization is the fourth step in the case of risk assessment process. Next, we have risk management. What is risk management? We'll see. Decision making process. As I told you, know, in the factory or in the pharmaceutical industry, somewhere when the spillage, when the certain, then management will sit, policymakers will sit, socio-economic people will sit, and they'll decide. Okay, let's take this step in order to safeguard the population. So decision making process involving considerations of political, social, economic, and technical factors with relevant risk assessment information relating to a hazard, so as to develop, analyze, and compare regulatory and non-regulatory options, and to select the implement appropriate regulatory response to the hazard. For example, so now there is currently there is a conflict going in between Iran and America. So a lot of oil spillage is taking place on that area, Strait of Hormuz. Okay, so that is the spillage, that is the threat, that is the hazard. Whatever the petroleum oil or is there. Now you have to take a decision how we can minimize the exposure to the marine life over there. Okay, prokaryotes, eukaryotes, or fish in that particular region, how we can safeguard that. So those decisions will be taken by this risk management only. That is the threat. The next steps how we can do. Okay, so risk management comprises of 3 elements: risk evaluation, emission and exposure control, risk monitoring. Once you make a decision, once you implement certain values, limits, then you have to make sure that implementation of that particular values will be there in the process. So for that reason, you need risk monitoring. So let's see what is risk evaluation. Risk evaluation, establishment of a qualitative and quantitative relationship between the risk and benefit of exposure to an agent, involving the complex process of determining the significance of the identified hazards and estimated risk to the system concerned or affected by exposure, as well as significance of benefits brought by the agent. So this risk evaluation, it is a part of the risk management. Risk evaluation is another name for this is risk benefit evaluation. Okay, so you need to do qualitative as well as quantitative relationship between the risk and the benefits of the exposure to that agent. It's a complex process. Okay, now we'll see few more last with respect to risk other definitions. One is risk monitoring. As I told you, once you implement, give okay. For example, in Delhi, air quality index is there, sulfur dioxide or nitrogen dioxide is there. They'll give you some ppm, 20 ppm or 30 ppm, like that. They will give you. Now you have to make implementation whether people are following that one or not. So risk monitoring will come under that particular umbrella. Process of following up the decision and actions within risk management in order to ascertain that risk containment or reduction with respect to a particular hazard is assured. Risk monitoring is an element of the risk management. For example, in the case of COVID time also, our Indian government has isolated certain areas. Okay, these are the more threat prone and like red zone areas. So they try to contain that area. So like that, they will be monitoring. They'll make sure that there is no flow of people or more exposure, unnecessary exposure of that particular virus. So think about examples and then you read, then you'll understand. Coming to risk estimation, we have seen before quantification of the probability, including attendant uncertainties that specific adverse effect will occur in an organism, system, subpopulation due to actual or predicted exposure. Certain times you can also, before getting exposed also, you can predict it. Okay, there's a leakage, there is a tendency that this much exposure will be there. So that risk estimation will be done by this toxicologist. Risk communication, interactive exchange of information about health and environmental risk among risk assessor, that is toxicologist will be involved, managers, news media. You have to flow the information because common people will also, if they're coming under the exposure, you have to intimate them also. Then interested groups as well as general public. For example, in the case of radiation hazard which took place in Japan or Chernobyl incident, that particular area or need to be evacuated. Then you have to communicate either through radio or through media. You need to communicate to the common people so that they will evacuate that particular area. Acceptable risk. So we have seen attributable risk, we have seen relative risk. Now we are coming about acceptable risk. This is a risk management term. The acceptability of the risk depends on the scientific data, social, economic, and political factors, and on the perceived benefits arising from the exposure to an agent. For example, Chernobyl incident only. They know in that particular area in the in the Europe or Russia, I'm not remembering, that took place. Now that particular area is abandoned. Okay, now no longer common people are not staying in that particular area. So like that, this now they have accepted that that particular region is having a risk. So people are not exposed to that area. So that is an example, perfect example for acceptability of the risk. Okay, because in that case, in the radiation hazard, the high half life of that whatever the uranium is around 1,000 plus years, 200 1400 years. That there is no other way we could minimize that risk. So best thing is to stop the exposure. How? By evacuating the people from that exposed area. Okay. So same thing happened with Sivosa disaster also. You can read about Yellow Lake also. You can read about Japan, not Hiroshima, Japan, Japan nuclear accident. You can read even Hiroshima, Nagasaki also, that particular area. They will try to at least at the time of exposure. Now people vegetative growth of people, the city has been developed now, but at the time of accident they will evacuate that particular area. Okay, so another thing what I would request you is that since we are discussing about risk assessment, I would request you to go through chapter number 4, that is risk assessment. In that they are very clearly given the very good flow diagram to understand these terminologies known under risk assessment, hazard identification, dose response assessment, exposure assessment, and risk characterization. And we are discussing about risk management also, where we can go for control or substitute or inform to the common public and policy decision actions. Okay, so of the political context and risk management options, how the management will sit and take the final decisions. Okay, hope from this video you were able to learn about what we have tried to learn is relative risk, attributable risk. We have learned about the absolute risk. We have learned about different risk terminologies. Okay, thank you so much. Be curious. For any questions, you can always write a mail to arya.priyanka18@gmail.com. All the best for your exam.